Hi everyone. As I mentioned, I'm Jasmine, and today we're going through mathematical reasoning and thinking skills. So we're going to begin with mathematical reasoning just because it's the next subsequent section in the selective and OC exam. Um, the tips that I will be sharing will apply to both OC and selective, but the sample questions that I've used are from the selective exam just because they have a higher level of difficulty. So mathematical reasoning features various types of questions that draw upon mathematical, spatial, and logical knowledge. So here I've noted the key features as well as some key concepts tested in each feature for your reference. For the sake of time, I'm not going to go through all of them, but make sure to note this down. And I'll be going through specifically some key features within some questions. For mathematical reasoning, I have two main tips. Firstly, fundamentals. So your fundamentals acts as a foundation for all types of question solving. So you must be extremely confident with your basic arithmetic and operation. So this means multiplication, division, addition, subtraction. We most often see two-digit by two-digit addition, two-digit by two-digit multiplication, division, or possibly three. So it's very important that you're confident with these without a calculator because you won't have a calculator in the OC and selective exam. And speed and accuracy are most important here because you're under time pressure. You need to be quick with your arithmetic, but you also need to be accurate so that you can get the correct answers. Also know your basic formulas because you won't have a reference sheet or something that you can Google or look up. You need to know these by heart. But how do you actually achieve this? So I've given you a mechanism, which is how you can improve this. And the most efficient way is to complete sheets of speed, multiplication, and division and time yourself. Since students most struggle with multiplication and division, you should be aiming for improvement in speed and accuracy in these two. So I put an example on the right side of the slide. This is something that you should be printing out and timing yourself each time you complete one. And obviously you should be marking it afterwards to see how accurate you are. I would suggest that you're completing this at least once a day and you're aiming for, again, both improvement in your speed and accuracy. So your time should be shorter and the number of answers that you're going to correct should be increasing. Don't use a calculator when you're doing your practice exams as well, because you should be constantly completing these calculations by yourself. And also don't be Googling your formulas when you're completing your practice exams. You should be recalling these from memory because that's the best way you can memorize it, active recall. My second tip is practice exams. So obviously one of the most efficient ways to be preparing for your OC and selective exams is to do practice exams. But it's really important the way that you do these practice exams. It doesn't matter about quantity, it matters about your quality. So you should be doing your practice exams with the full allocated time, which is 40 minutes for selective. No matter if you finish early, practice using scrap paper mindfully. Just because the selective and OC exam are moving towards a more online-based computer exam, we actually don't quite know the situation with scrap paper yet. So it's really important that you're practicing using less, but still maintaining your working out to be clear and easy to read. And obviously always be revising your missed questions after. But in saying this, the way you should be revising your missed questions is don't credit your incorrect answers as simple, silly mistakes. It's a very common habit, and it causes students to not be able to improve their incorrect answers and incorrect questions. Also, be very careful to also revise questions that you may have made an educated guess on and you've gotten correct. These questions you should be noting down because you want to be absolutely sure with almost every question that you're answering. All right, with the silly mistakes, you have to analyze why this mistake happened. All mistakes have a reason behind them, even if it's sort of called maybe like a little bit silly. So maybe you're feeling rushed because of time, because you were on a couple last questions and you only had a couple of minutes left. Or maybe your handwriting was messy when you were writing on scrap paper and you've misread a number. These are the reasons that you should be looking for. So analyze firstly what the mistake was and why it happened, and that will allow you to figure out how to fix it. At BrainBuds, we're actively integrating these self-reflective elements to equip our students with the skills to approach all future questions with confidence and also with efficiency, and make sure that they're answering these questions correctly. Now I'm going to go through a couple of questions just to show you my method and how my method it's the most efficient and how I can aim for the most accuracy. I will be turning off my camera just for now because I will be writing. All right. So, apologies. Let's look at question 21. So question 21, I immediately see a graph and I'm thinking I need to be analyzing this graph and extrapolating data from this graph. So the first thing I do is I will be looking at the X and Y axes. So the X and Y axes are your two labels here. You should be looking for units, labeling, and where 0 starts. So as I can see, both start from 0, so that's not as much of a problem here. But you should be observing these firstly. Don't look at the graph, look at these first. And because a lot of common tricks are here, they'll use different units in the question and on the X and Y axes to confuse you. So always check your units, always check your labels. Then for these type of statement questions, you should be evaluating each statement individually and approach it from top to bottom. So here I'm going to start with X first. So X, at any height above sea level, the fraction of nitrogen is higher than the fraction of helium. So here I can see nitrogen and helium here. And I'm comparing height at above sea level. So already, because I looked at the x-axis, I know that my x-axis is height above sea level. I'm looking for where nitrogen is always higher than helium. But I can see that this is actually incorrect because at 600 kilometers, we already see that helium comparatively is higher than nitrogen. So X I can label as incorrect. Y, there is more than one height at which the fractions of oxygen and helium are the same. So here I'm looking for where the oxygen and helium lines intersect because this means where they are equal. And here I can see they only intersect once, and this is at about 450 kilometers above sea level. So I can also say that this is incorrect because we only have one height where the fractions are equal. Z, at 200 kilometers above sea level, the air is about half nitrogen and half oxygen. So I know 200 kilometers above sea level is here, again, because I've reviewed the x-axis, and I know half fraction of air is here because I've reviewed the y-axis. So here, if I draw where these two data points align, then I can see actually both nitrogen and oxygen are passing through this point, which means that Z is correct, and hence statement Z only is the correct option in this question. All right, we'll be moving on to the next question. So this next question is has two main methods. I'll go through both methods because I think both are quite efficient and you can see which one you like more. It also just depends what you think of in the exam. So here we're given a pattern of boxes is drawn on a grid. Box 1 is at reference B2, box 2 is at reference C3, and so on. So they've actually given you how to reference these grids, but you should be aware of this already. And hopefully, if you play chess or some sort of games like that, you should be knowledgeable of these grid references or looking at maps. So the first method is to approach the pattern as a repeating unit of 9. So here are the 9 boxes that I'm given. I'm going to use this as a repeating pattern. And so I'm asked to find the grid reference of box 40. So 40 is the number that I'm really looking at. So to find how many times this pattern of 9 repeats, I'm going to divide 40 by 9, which gives me 4, remainder 4. So now I know this pattern repeats 4 times and remainder 4. I'm not too concerned about the 4 times now because I'm just trying to look at the position, but what's really important is the remainder 4 here. So I know this is remainder 1, this is remainder 2, this is remainder 3, and this is remainder 4. Since 40 has remainder 4, I know immediately that it's in column B, this column. Now I can eliminate these two options, but now I need to find the number of the grid reference. So I look at the pattern, the number pattern, and the number of the box is 1 less than the number of the grid reference. So I look, for example, at 8. 8 is 1 less than 9. 6 is 1 less than 7. So the rule is n plus 1 equals grid reference, where the n is the number of the box, so the gray box. So here I can see 40. 40 plus 1 is 41, so the correct answer is the first option, or A. which we can confirm as correct. But I'll be going through the second method quickly. So the second method is where we approach the pattern as a repeating unit of 3, looking at the columns specifically. So column B, column C, column D. So we're looking at these 3 columns just because our pattern only occurs here. When we look at the pattern as a repeating unit of 3, I'm thinking about dividing it by 3. So here I can see in column B, when I divide my number by 3, I have a remainder of 1. So for example, if I divide 4 by 3, it's 1, remainder 1. If I divide 7 by 3, it's 2, remainder 1. And 1 is obviously 1. So here we can have B is remainder, is remainder 1. If we look at column C, when the number is divided by 3, we have remainder 2. If we look at column D, when the number is divided by 3, we have remainder 0, because all these numbers are divisible by 3. Okay, now we're trying to look at box 4 again. 40, sorry. 40 is divisible by 3. When we divide 40 by 3, we have 13, remainder 1. So this is our information that we're looking at, remainder 1. Again, that's giving us column B. So again, we can cross these out. And the number pattern is the same, n plus 1 as so again. So again, B 41. So as you can see, there's multiple ways to analyze a pattern. It's whatever you're most comfortable with, whatever your mind discovers. And so just be aware that there's multiple patterns or methods that you can see. So that's question 23. Now this is the final question, question 27. So firstly, I will note that these type of questions occur quite often. They're asking you to look at numbers and what a person is thinking of. They give you these properties of these numbers and they're asking you to find out what number or what numbers it is. So here the question is actually asking for the sum of all the numbers Mateo could be thinking of. This is adding just another layer of difficulty, so students can't work backwards. For example, if they just said, what is a number? Students could be working backwards to find the number. But yes, so this is just adding another layer of difficulty. So here, if I'm looking at the information here, Mateo is thinking of a whole number. So this is whole, that's very important. If he multiplies his number by 3, the answer is less than 30. If he multiplies his number by 6, the answer is greater than 40. There's more than one number, and we know that because it's the numbers, it's plural. So when he multiplies his number by 3, the answer is less than 30. I'm going to use algebraic reasoning here. So I'm going to let Mateo's number be x. So when he multiplies his number by 3, the answer is less than 30. 3x less than 30. Here I'm using inequality signs, which you should be familiar with in your primary school teaching. Since both sides are divisible by 3, I'm just going to simplify this so I have a bit more of a specific range. Therefore, x is less than 10. That's the first piece of information I'm looking at. If he multiplies his number by 6, the answer is greater than 40. 40, unfortunately, is not divisible by 6, but we can approximate it as 6.66 or 6 2/3. So this is my second piece of information. And when I add these two together, then not add these two, but I'm combining these into a range for my x. Then here I'm given my range, but it's only whole numbers. And we've noted that down by circling whole. So the numbers that fall into this range are 8, 7, and 9, which sum to 24. And we can confirm this as correct. And so that's, this is our last question. 3 planks of wood all have the same length. They are placed next to each other as shown. So this is from the 2022 selective exam. So firstly, I'm immediately drawn to this information. 3 planks of wood all have the same length. Very key information here. And if I'm thinking about this, if the 3 planks were laid out side by side, we could simply divide the total by 3 since they're the same length. But unfortunately, we're not given this situation because, again, it's a bit too simple. So our method is to try and attain the scenario with the information given. So the total length of the overlapping planks is 135 centimeters. If we were to add the area of the overlapping plank area, we would have the total length of 3 planks as if laid out side by side. What I mean is this overlapping area here and this overlapping area here, that's the length that is covered up, the length that is hidden in this 135 centimeter figure. So we're trying to add this overlapping area to make it seem as if they were laid out side by side. So here I'm not adding any additional plank length. I'm not removing any plank length. I'm simply moving it. So 135, which is our overlapping area, our overlap plank length, and 45, which is our overlap area, gives us 180 centimeters. And since they're all the same in length, 180 divided by 3 equals 60 cm, which gives us C. So again, the main trick here is to be looking at your key information and thinking, how can I use this key information in this scenario that I'm given? Okay,